In coordinate geometry, we have to find the equation of straight line under different conditions. From 2 points, we can draw a fixed straight line. If we have 2 points, we can draw one line passing through this 2 point, and this is the only line which passes through 2 points. If only one point is given, we can draw infinite lines from this point, and these infinite lines are called concurrent lines. Okay, now if we want to draw a fixed line from one point, we should be given another point, so that from 2 points we can draw one fixed line, or we should be given point and direction. Suppose it is given that line is drawn from point 2, 1 and which makes an angle some theta with x-axis, positive x-axis. So line is passing through this point and makes an angle theta with positive x-axis. Now here there are two specifications are given for line. One is point through which line passes, and one is angle with positive x-axis, or we can say direction of the line is given. So when one point and direction of line is given, we can draw one fixed line. Now in coordinate geometry, direction of line is defined as slope of line. Now, what is definition of slope? If line makes an angle theta with positive x-axis, this is positive direction of x-axis, then slope is defined as tangent of this angle. So slope is tan theta. Suppose we are constructing one right angle triangle here. This is 90 degree, this is 90 degree. Then this angle will be theta. So slope is, suppose this is triangle ABC, then slope is equal to AB upon BC. From definition of tan theta, that is opposite side upon adjacent side. So slope is defined as this height upon horizontal distance, or slope is defined as ratio of altitude change to horizontal distance. जैसे अगर हम हॉरिजॉन्टल प्लेन पे सपोज BC डिस्टेंस ट्रैवल कर रहे हैं तो हमारा अल्टीट्यूड कितना चेंज होगा, AB. तो इसका जो रेशियो है AB अपॉन BC, दैट इज डिफाइंड एज स्लोप. नाउ if we take this line, now this line is steeper. So if we construct any right angle triangle here, then these two angles are same. If this is alpha, this is alpha, then slope of this line is tan alpha. Obviously here value of tan alpha is more than tan theta, because alpha is greater than theta, then tan alpha greater than tan theta, because alpha and theta are acute angles. Now this line is steeper That means this line has more slope. Now slope is denoted by one standard symbol, that is m. So slope is now m, which is equal to tan theta, where theta is angle of straight line with positive direction of x-axis. Okay, now value of slope can be either positive or negative. For this line, angle with x-axis is theta, which is acute angle, and we know that for acute angle value of tan theta is positive, or we can say when angle of line with positive direction of x-axis is acute one, then slope is positive. But for this line, angle alpha with x-axis is obtuse. Then slope of line is equal to tan alpha, and tan alpha is less than 0. We know that for obtuse angle value of tan is negative. So slope is negative when line makes obtuse angle with x-axis, and slope is positive when line makes acute angle with x-axis. To get the value of slope, the value of theta varies between 0 to pi. For example, if line is making an angle theta with x-axis like this, then slope is positive. If line is like this, that means angle of line with x-axis decreasing, angle is becoming smaller and smaller, that means value of tan theta will decrease. We know that when value of theta decreases, tan decreases, because tan is increasing function. Now here theta is becoming smaller, the value of tan theta becomes more smaller, and when this line is parallel to x-axis, जब लाइन x एक्सिस के पैरेलल होगा तो उसका x एक्सिस के साथ एंगल क्या हो जाएगा, 0 डिग्री. देन स्लोप ऑफ लाइन पैरेलल टू x एक्सिस, स्लोप इज tan 0, that is 0. Now when line is rotating like this in anti-clockwise direction, the value of theta increases, that means slope is increasing. When line is perpendicular to x-axis or parallel to y-axis, this angle is what, 90 degree. Then for line is parallel to y-axis, slope is equal to tan 90 degree. Now we know that tan 90 degree is not defined because cos 90 degree is 0. So for vertical line or line parallel to y-axis, we have slope m is equal to tan of tends to 90 degree, or we say this is limit theta tends to 90 degree of tan theta. We cannot take angle exactly 90 degree, but we can take angle very close to 90 degree, or we can say theta approaches to 90 degree. Or in terms of limits, we can write limit theta tends to 90 degree value of tan theta, and this value approaches to what? Infinity. This is infinity because when theta approaches to 90 degree, we have tan theta as a ratio sin theta upon cos theta. When theta tends to 90 degree, sin theta approaches to 1, but cos theta approaches to what? 0. Now tends to 1 upon tends to 0, this value approaches to infinity, which is plus infinity, positive infinity. So remember, when line is parallel to y-axis, slope is always tends to infinity, and when line is parallel to x-axis, slope is 0. Now further, if line rotates and in anti-clockwise direction, suppose line is here. Now this angle theta with positive x-axis is obtuse. So in this case slope is negative. If line is rotating again, that means line makes more obtuse angle with x-axis, then slope is becoming, we can say slope is becoming now less negative. If line is making more obtuse angle with x-axis, means angle theta approaches to 180 degree, then tan theta is negative, but it is approaching to what? 0. And when again line is parallel to x-axis, slope will approach to what? 0. Or when line is horizontal, slope is 0. So when from this position, if line is rotating like this clockwise, slope is becoming negative, and if again it is moving, slope is becoming more negative. Okay, if it is rotating, then slope is becoming again more negative. And when line is almost parallel to y-axis, slope approaches to what? Minus infinity. But when line is exactly perpendicular, then we define slope as plus infinity. We know that when theta is approaching to 90 degree, tan theta is either plus infinity when theta is less than 90 degree, or tan theta tends to minus infinity when theta is slightly more than 90 degree. But when line is perpendicular, conventionally we define slope as plus infinity. That time we consider angle theta not slightly more than 90 but slightly less than 90 degree. Let's see now slope of line joining two points. If two points are given, how to calculate slope of line? Suppose two points given are x1 y1 and x2 y2. This is P point x1 comma y1 and this is Q point x2 comma y2. Now these 2 points are given. We want to calculate slope of line. For that we construct here the right angle triangle. Now this angle is theta, then slope of line is m is equal to tan theta. Suppose this point is R, this angle is 90, this is also 90 degree angle. Triangle PRQ is right angle triangle. Now, what is this height? This height is y2 and this height is y1. So QR is equal to y2 minus y1. Further, this width is x2 and this width is x1. Then PR is equal to x2 minus x1. Then slope is equal to m is equal to tan theta from this triangle, triangle PRQ, that is opposite side QR upon adjacent side PR, that is y2 minus y1 over x2 minus x1. So we have now formula for slope of line joining two points, that is difference of y coordinate upon difference of x coordinate. But we should take the difference in the same order. If we have y2 minus y1, we should have here x2 minus x1. Let's find now slope of line given by equation ax plus by plus c is equal to 0. We know that linear equation in x and y is straight line equation. Okay, first of all, let's draw this line, or let's find 2 points on the line. If we are able to find 2 points on the line, we will have slope of line using formula difference of y coordinate upon difference of x coordinate. 2 points on the line, for that consider x is equal to 0, then value of y is minus c upon b, and consider y is equal to 0, then value of x is minus c upon a. So there are 2 points on the line, minus c upon a comma 0, and another point is 0 comma minus c upon b. Join these 2 points. Okay, then slope of this line is difference of y coordinate, that is minus c upon b minus 0 upon difference of x coordinate, that is 0 minus c upon a. Then this is minus c upon b over c upon a, or minus a upon b. So we have now formula to find slope of line when its equation is given, that is minus coefficient of x upon coefficient of y.